Moving on to part B, we need to, here we have 2.67 grams of magnesium oxide that is added to 200 centimeter cube of 2 mole per decimeter cube HCl. Calculate the amount in mole magnesium 5 oxide, magnesium 4 oxide. So, molar mass of Mn is basically 55 and molar mass of oxygen is 16. So, the molar mass of MnO2 is 55 plus 2 times 16. So, this comes out to be as, just a second, yeah, it comes out to be as 87 grams per mole. Okay, so number of moles is basically given weight by molar mass, that is 2.67 divided by 87. So this finally comes out to be as 0.0307 moles. Okay, and that's the final answer to this question. Now, moving on to the next part, we need to find out the limiting reactant for this question. Now, I've already mentioned the reaction and the given information to us. We calculated the moles of MnO2 in the previous part. So, yeah. So, to calculate the limiting reactant, we need to find out, we need to know the moles of each of the components. So, moles of MnO2, so this is for moles, would be 0.0307. Moles of HCl would be 2 mole per dm cube times 200 divided by 1000 dm cube. Okay, so finally this would be 0.4 moles. Okay, let me just recheck my calculations. So yeah, it would be 0.4. Now we would be using the magic ratio trick. That is n by stoichiometric coefficient of O2, that is moles per stoichiometric coefficient of MnO2, sorry. So here the moles of MnO2 is 0.0307 and the stoichiometric coefficient is 1. So this is for MnO2, and n by SC of HCl would be 0.4 by 4, that is 0.1. So as you see, n by SC of MnO2 is less than that of n by SC of HCl. Therefore, MnO2 is our limiting reagent. Okay, determine the excess amount in mole of the other reactant. Okay, so see, total there is 0.1 mole, 0.04 moles of HCl, and therefore there is 0.0307 moles of MnO4. So moles of HCl reacted would be, we need to apply the stoichiometry between MnO2 and HCl. Okay, so it would be, it is obviously in 1:4 ratio. So 1 by 4 times 0.0307. Okay, I believe there was a little error here. So it won't be 1 by 4, it would be 4 times. Okay, because it's HCl and MnO2. So 4 times, so 4 times 0.0307 would be 0.1228. Okay, so moles of HCl in excess would be total moles minus the amount that has been reacted. So our final answer comes out to be as 0.2772 moles. Okay, you can round it off to 2.77 also, not an issue. Okay, so in the next part, we need to calculate the volume of chlorine in dm cube produced if the reaction is conducted at standard temperature and pressure. Okay, so firstly, let's calculate the amount of moles of chlorine that would be produced. We've already calculated that MnO2 is our limiting reagent. So 1 mole of MnO2, and MnO2 and Cl2 is in 1:1 ratio. So moles of Cl2 would be equal to moles of MnO2, that is 0.0307. Volume of Cl2 would be, in your booklet it would be given that for 1 mole it is 22.4 liters. Okay, so we would just multiply it with this thing, and unit would be dm cube or liters, both are the same thing. So our final answer would be, yeah, so final answer is 0.68 8 dm cube. In the next part, we need to find out the oxidation state of manganese in MnO2 and MnCl2. Okay, it's also again fairly simple. Let's assume that oxidation state of manganese in both of them are plus X. Okay, then MnO2 plus X plus 2 times oxidation state of oxygen with MnO2 is -2 would be equal to 0 because this is a neutral molecule. So X is equal to +4. So in the first compound, the oxidation state of manganese is +4. In the second one, let's assume it to be as X, and we have twice Cl. Cl has a -1 oxidation state. So X is equal to +2. So in the second one, the oxidation state of manganese in MnCl2 is +2. Okay. So reduce referring to oxidation state whether MnO2 is an oxidizing or a reducing agent. So see MnO2 or the Mn in O2 the manganese in MnO2, it is getting reduced. It is going from +4 to +2. Something which gets reduced is known as the oxidizing agent. Okay, so MnO2 here is basically an oxidizing agent. So anything which itself gets reduced will oxidize the others. That's why it's known as the oxidizing agent. In the next question, it is given that chlorine gas reacts with water to produce hypochlorous acid and hypochloric acid. Hypochlorous acid is considered a weak acid. Outline what is meant by the term weak acid. Weak acid is an acid that dissociates weakly or dissociates partially in water. Okay, or rather you can use the word ionizes too. So ionizes partially in water. Okay, so this is a weak acid. State the formula of conjugate base of hypochlorous acid. Okay, so how do we write the conjugate base of an acid? We remove an H plus ion from the compound. So from HClO, if you remove an H plus, what you are left is ClO minus. So ClO minus is our conjugate base. Okay, so this is the answer, ClO minus. Calculate the concentration of H plus in HClO with a pH 3.61. We know that pH is basically minus log of H plus ion concentration. This is 3.61. So H plus ion concentration is 10 to the power minus 3.61. Okay, so when we plug this value in our calculator, what we get is 2.45 times 10 to the power minus 4 mole per dm cube, and this is our final answer.